When I started learning streams, I started by reading documents, which helped me understand concepts. However, my code still looked like this. So I was still using for loops and not utilizing stream that effectively. It is only when I started solving problems, streams really clicked. And after that, I could always write a code using Streams API instead of relying on loops. So I want to take the same approach in this series where we are going to solve multiple problems to understand and create an intuition about streams, and so that we can write better code using streams. So this is the first session of the series. Now, before we jump into the code, I just want to take a brief moment to look at what streams really are. So streams are basically sequence of element from source, and we can create a pipeline to process this sequence of elements. The pipelines are created by providing a chain of operations which gives us a results. And usually streams are created in three parts. There is a source which gives you a sequence of elements. Then there are intermediate operations which converts those sequence into another sequence. And then there is a terminal operation. And until we use terminal operation, streams are not evaluated. So streams are lazily evaluated. It is only when we give them terminal operation. So to take an example, we might create a stream using collections.streams, and then we can apply intermediate operations like filter, map, limit, which would provide output as a stream only. And when we want to utilize that output, you can use some terminal operation like collect here. Now look, what we are going to do in this series is in this video specifically, is we are going to solve 8 simple real coding problems. And we'll look at loop version first, and then we will convert it into the stream version. We are going to use some employee data set that I have created for solving all these problems. So you don't have to worry about this data set, etc., because all the code is available in a GitHub, and the link is provided in description. Now this is the first part of this series, and we are going to do a lot more problems subsequently in the subsequent session in the series. So if you are interested, please don't forget to subscribe so that you will get notified whenever I upload the next video. Now, before we start solving the problem, let's look at this project structure that I have created. And let's look at the data that we are going to use to solve all these problems. So I have created this employee class, and it has few fields like ID, name, department, role, etc. And some of these fields are actually enum. So if you can see here, department is enum with various department, right? Where IT, HR, marketing, sales, etc. And similarly, there are multiple fields here. And I have overloaded toString method. Also, there are getter and setter. Apart from this, I have created this employee data class, which gives us like set of employees, a list of employees through which we can do some operations, like on which we can do some operations. And all this code, as I mentioned, right, it is available in the GitHub. So you don't need to write it yourself. You can simply clone the repo and you can practice the problem yourself as well. So now let's jump into the first problem. We are going to solve these 8 problems. Let's start with the first problem. Now, the first problem is we need to, given a list of employee objects, we need to filter and return all employees who work in IT department and have salary greater than 90,000. Now, here is the for loop example for this problem. So here what we need is we have the input as employees, and we also need output as employees who are from the limited department and limited with some criteria of salary. So our input is list of employee, our output is also a list of employee. And this is the way we usually solve this problem using for. Now let's see how we can solve this same using the Streams API. Now, when we want basically output result here, so I'm going to keep the same result variable here, and what we are going to do is use employees dot stream API first to get stream from these collections. Now think about the problem that we are trying to solve. We have input employees, and what we need is a output as an employee. So we have list of employee and we need to convert them to a list of employees. So when we do employees.stream, what we get is a stream of employees. And what we need again is a stream of employees with filtered set of results. So for that, the operation that we need to use is a filter. Now filter takes predicate, which returns boolean, and whatever conditions, whatever elements in the stream which satisfy this condition, those are only added to the filtered stream. So what condition you have to use, we need to use the same condition. So I'm going to write the same condition here. That is, we need to write a lambda expression. So e gives, and then we can do like .it dot equals e dot get department, and then we want to make sure that the salary of the employee is greater than 90,000. Okay, so this way we will get a filter stream. However, we need to convert the stream into list again so that we can print it. So the terminal operation that I'm going to use here is collect terminal operation and collector dot, and there are some additional methods which are provided, which is collectors dot. Now if you are using a latest version of Java, there is toList method here which can be also utilized. This way now you will see we can print the result now and see what is the output of both this. So if you see here, both the for loop as well as the streaming solution are giving the same output. So they are filtered some list of employees. Now if you see, it has employee John Miller, whose department is IT. Then it has employee Olivia Davis, same with department is IT and salary more than 90,000. So this is way we have done the filtering operation first. Okay, so we'll look at the second problem now. Now let's look at problem number 2. Now I have kept this problem similar and slightly different because I wanted to introduce a new intermediate operation here. So in this case, the problem is we need to get the names of all IT employees earning more than 19,000 as a list of string. So basically, earlier we had like IT employees plus 90,000 as a filter criteria in previous problem. Here, we don't need all employees. We need names of the employees. So our input is list of employees, but our output is list of string. So here is a for loop version of the problem, and let's see how we can solve it using the using maybe a streams version. So what I'm going to do, I'm going to use a different list here which I have created, name list. And first thing first, we will create employees dot stream to get stream of employees. I will then apply filter criteria which would be similar to what we did earlier in the same problem. So employee, so we need to define E here for the same, and E dot get department, E dot get salary is greater than 90,000. Now here if we collect again, we will get list of employees, but we don't need that. We need a list of strings. So we need to convert this stream of employee into a stream of string. Whenever we need to map a particular type of stream to another type of stream, there is an operation that we need to use is a map. So operation that we need to use here is a map. So what we will do, we need to map employee object to the employee's name. So e dot get name, and we can actually use lambda, basically method reference here. So let me first add toList here. So before Java 16, we used to write something like collectors dot toList inside collect function. However, Java 16, since Java 16 onwards, there is this new method added, toList, which we can utilize instead of writing so much of code. So now, instead of using e gives e dot get name, there is another way we can write this, which is using method reference. So if you want to use method reference, you can do something like this: employee colon get name. So this way, what we are doing here, so if you see here, we are getting stream of employee here. Then we are filtering the stream of employee using the filter criteria. And then we are mapping that employee to a string by getting the employee.getName. And then converting it into the list of string. Now if I run this program, I should ideally see the same output for loop as well as on the stream API. So let's see that. Now if you see here, we have printed the name of the employees using the map function. Now let's look at a third problem here. So in this problem, what we need to do is we need to get a list of all testing departments present in the company. So if you look at the solution without streams, you see that we have created a set. Why set? Because we need distinct department, and here is a set of type department. And then we are iterating all employees in the list and just adding the department, since set would only keep the unique or distinct values. It would only add the distinct value. And since we wanted a list eventually as output, we are converting that set into the list and then printing it. Now let's try to solve the same problem using streams solution. So in case of streams, what we need is output as a departments, and departments is list of employee dot department. So let's start with creating stream first. This would give us stream of employees. However, what we need is not stream of employee. What we need is employee dot department or list of employee dot department. So since we need to change the type or change the data here, so what would we do? We will use map here. So, and we will use map to get department, since we need to convert the employee to a department list. Now, in order to know, since this would give us like, if I do it toList now and run this program, what I would get is, now if I run this program now, if you see, the for loop version has created a printed distinct department. However, our version has publish all the elements in the list. So how do we prevent that? So there is a function in stream which is called as distinct. And if we like after mapping, if we put the distinct as intermediate operation before toList, all the duplicates from this mapped stream of department would be removed, and this would give us the distinct list of departments. So let me run the program again. So if you see now, with distinct, we are able to get all the different departments which are there rather than adding them as a duplicate. So this is the another intermediate operation that we learned by solving this problem. Now for problem number 4, we have here a bit complicated problem here. So if you see, what we need to do is we need to find the top 3 highest paid IT employees and return them as a list. So our input is employees list. Our output is also employees list, but what we need is IT employees with highest paid, top 3 highest paid IT employees. So if you want to do it using for loop, we need to first filter out IT employees, and then we need to sort them using their salary, and we need to sort them in a descending order. So that way we can get the sorted list, and then to get only top 3, we might need to iterate those and get the first 3 added to the another list, and then we can print the top 3 here. Now let's try to achieve same using the stream API. So we will start here step by step. Like we'll keep our left hand side the output that we want to get, and we will start by creating stream first. Now this will give us stream of employees, and we know how to filter the IT employees, right? So we will apply the same filtering that is here. So e dot get department, or in other way we can put it like employee dot department. Now next step that we need to do is we need to sort them. So for this, actually a stream has provided a function, intermediate operation, which is sorted and which takes comparator as an input. So if we provide a comparator to compare the values against which we need to sort the list. Now we are going to use comparator.comparing function to create a comparator, and this function would take a value against which we need to do the comparison. Since we need to sort by salary, what I would do is I will provide method reference to employees get salary. Now this comparator.comparing would return a comparator that would compare the salaries. And let me simply convert it to list for now, and we'll see the output just as a test run. So to see what we are getting as output. Now if you see here, this is the original output from the for loop example, and you can see that we will see list of 3 employees here in the first phase, and they are sorted by descending order of their salaries. So 1,25,000 is first, and then 98,000 is second, and 95,000 is third. However, our list is sorted by ascending order, and also it has all the 4 employees and not limited to 3. So first thing, how do we sort it in a reverse order? So basically by default, comparator comparing would compare by natural order of the elements, which is ascending order. However, since we need to reverse the ordering here, we need to have them in descending order. What we can do is we can call reversed on the comparator written by comparator.comparing, and we will get the reversed comparator. Also, since we do not want to list all the 4 employees, we need only top 3. So there is a function provided in Stream API which allows us to limit the number of elements, and we can provide the max size. So if we provide 3, it would only limit the list to the maximum of size 3. So now let's run again. Now if you see, now we have same output as that of a for loop. So we were able to achieve the same thing, that listing top 3 employees or top 3 IT employees by descending order of their salary using the Streams API. So the function that we learned here are sorted and limit. The sorted allows you to sort the stream of elements, and limit would allow you to limit the number of elements in subsequent stream. Now, problem number 5 is very complex when we have to do it using a for loop, and with stream it becomes very simple. So here what we need to do is, in this problem, we need to return a second page of active employees with page size of 3. What it means is we need to skip first 3 active employees and then take next 3 active employees. Now if you look at the for loop code that I have written for the same, it's like it had to handle very edge cases, etc. So it became a bit complex. Now let's write a stream version of it. So first thing first, what we need eventually is active employees and second page. So let me use the same variable active employees here, and as we did in earlier example, we will first create a stream. Now if you see, we only need active employee, so what I'm going to use is filter here. And since there is simple function that we need to call, that employee dot is active, we can also use method reference here, employee : is active. Then since we don't need to show first 3 elements, there is a function in stream which is skip, and it would skip initial 3 elements, and after that we don't have to show all the employees, but we need to limit it to 3 only. So this way we are skipping first page and then limiting the rest of the elements to the size of 3, so that we are showing the next page with size of 3. And we just need to add toList here, and we can simply put active employees. So if you see here, what we did here is we use filter to basically get the active employee stream from the stream of employees. Then we use the skip function, which would skip the first n number of elements, and then we limited it with 3, so we can only print the next 3 elements. And we can simply print this list now running the program. And if you see, we have printed, we actually created the same list here as above. So there are 3 employees here, all are active. So let's look at 6th problem now. The problem statement says we need to get the names of the 5 youngest active employees as a list of string. Now, how do you find youngest active employees? So basically, if you look at employee data, there is this active field for each employee, which should be true. And to find the youngest one, we need to sort by age. So let's do the stream version. I'm not going to go through the for loop version. The entire code is committed in a GitHub repo. You can clone yourself and take a look at for loop version. So how can we do it? We need to basically create a list of names, so which is a list of strings. So I have already created variable above, so I'm going to use the same variable. Then what we would do is employees.stream. Now first we need to figure out who are the active employees. So as we have seen, there is a is active method on employee, which would return a boolean. So we can directly use it as a method reference inside a filter function. So this would give us list of active employee. However, now we need them to sort first. And for sorting, what we are going to use is comparator. We need to pass a comparator. So comparator.comparing, and we need to compare them by age, because we need to sort them by age. Once we sort them, we need to only print 5 employees. So we saw the function to do it, which is limit. So we'll pass limit with 5. This way we would limit the output to the 5 employees only. Also we don't want to convert it to list of employees. We want to map it to the only name. So what we can do is we can map to a string using get name, since we only need name inside a list. And then we can convert this to toList. So we can convert it to list of strings using the toList function. So if you see, we started with stream of employee, and when we applied map, it became stream of string. Now let's run and see how the two outputs look, one with a for loop and one with the streams. As you can see, both the outputs looks correct. So basically we printed youngest employees, which are active, and we limited only 5 employees from the list. Now our problem number 7 is about getting distinct location names as strings like London, New York, etc. So we want to get distinct location names. So I will, as we have done in the for loop example, we want to do it using the streams. So what I would do, I will use the same output variable here, and I will, as usual, I will get employees.stream first. Here, think about it. What we need is location. So first we need to convert this list of stream of employees to stream of locations, and for that what we can use map. So we can map stream of employees to a stream of location using employee dot get location, but this would give a stream of enum and not string. So, but we can again map it to, so we need to, so here we are getting stream of location and we need to convert it into stream of string. So how to do it? So enum has another method which is enum dot name, and it should give us the string version of the element. Now when I click dot here and convert it to toList, it will give me list of string. But we also need distinct location, so we can apply distinct as an intermediate operation here. And let's print locations and run this program. If you see now, we are able to print distinct locations from each employee. So now let's start with our last problem here. So in this case, we want to find a number of full-time employees from the employees list. So in order to do it, I will define one long variable and I will call it stream count, just to distinguish from the count variable above, which we have used for loop example. As again, we will start with employees.stream here. And what we need to do is we need to filter first employee by employment type, and employment type being full-time. So we need to define a lambda expression here where we will filter all the employees whose employment type equals full-time. So e dot get employment type is full-time. Then what we need to do here, since we need to find the number of elements in a stream, we are going to use a new terminal operation here, which is count. We haven't seen this before, but this terminal operation returns a long, and it basically returns the count of element in the stream. So after filtering the number of employees which are there in the stream, those would be counted. So let's again print this stream count as well. So instead of count, I will make it stream count and just add a stream here. And now we can run this program. So you can see both the for loop and stream version have given the count of full-time employees, which is rightly 8. So in this video so far we covered 8 simple real coding problems using the streams. All this code is available on the GitHub link, and the link is in the description. So you can clone this repo and practice it yourself as well. What we did here is we looked at loop version and converted into the stream version. Going forward, I am going to look at more advanced problem in this series. So we are going to look at additional intermediate operation as well as collection operations. So if you are interested in learning those, please remember to subscribe the channel.